Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at some of the errors you can get from the linker when you make a minor mistake that is, frankly, rather easy to make. Then, we're also going to take a look at what are known as makefiles. And these happen to be something that we honestly don't need for what we're currently doing using Eclipse, but in case you were to use something such as Unix or Linux or Mac, in case you want to compile stuff without something such as Eclipse here, or in case you want to compile things using your command prompt, you would end up using a makefile. And this helps to demonstrate how the linker is different than the compiler. So this just happens to be a good example of what we're actually looking to do here. So for now, let's take a look at some of the problems you can get yourself into with the linker. The one that we covered in the previous episode is that as opposed to including these CPP files when I happen to have some thing that happens to be templated, if I go with the header files, it will not end up correctly linking all of the different things that I need. As a result, if I then build this here and pop open the console down here when it's done, you can see down here how it gives us this link error and gives us unresolved external symbol saying this. And there's many things that can mean. In this case here, it's just because we used templates and because we didn't include the actual source for it, and I go over why that's the case in the previous episode. Another common error that you can do, and for this one here, let's actually head on down to sorting, so as I can do this slightly differently. So we're going to open up our .hpp file, and use F3 to quickly hop into our CPP file and move that guy over here. So the way in which you do this is that in case, for example, one of these declarations doesn't match a definition in here, that will also give us a linker error. So for now, let's just pop open this guy so that we can easily see this one. I build it, and we can change one of these so as that this one here, let's go with, instead of an unsigned int, it's a char, which is actually something that can validly work for all of this. It'll give us issues, but then if we build this, you note down here how it happens to be giving us this error on merge, which, by the way, is what we ended up changing to have a char here. And once again, it's another linker error, similar to the other one, unresolved external symbol. And that's because our definition differs from our declaration. A much more common thing than seeing this where you have unsigned int start index, all of this sort of thing, is that in one spot, and this would be easier to show in our stuff actually using objects and the like, in case, for example, in link.cpp as opposed to link.hpp, in here, one of these where I have this link C pointer, if I had forgotten this asterisk here, then it will first off give you this, which is thankful because that actually happens to be a compilation error. But it is actually possible to occasionally get it so as that you wind up with a item over here that isn't declared the same as it is over in here. It's a bit easier in case, say, I take a look at some of these things such as our friend operator down here. So if I take a look at this and I just have it pass in a link here, that's probably not going to give us a compiler error, but instead going to give us a linker error. Yep. So some of it can be occasionally noticed by your compiler, but it is important to note that not always will something such as a difference between your declaration and definition be noticed by your compiler. Sometimes that has to be noticed by your linker. The other possible cause of a linker error is that, let's say that one of these we were expecting to be defined in some external library for us. In the event that for whatever reason, either we were using an out-of-date library that didn't have it defined, or some weirdness with the versioning caused it not to be defined, then the fact that it isn't defined is going to actually cause us a linker error in case we try to use that anywhere else. In this case here, yep, you can see in here how it's trying to find that operator, but it can't. It gives us this linker error. So those happen to be the common causes for different linker errors. Then, for a makefile, and this should really help to demonstrate the difference between the compiler and the linker for us. These are things that are going to be, you really aren't going to need them for this particular series. However, it's a matter of what they're used for primarily is that in case you have a larger project across multiple files on something that you're doing a more traditional form of compilation on, such as in here you'll notice I'm using G++, which happens to be the GNU version for the compiler. So what we're then also doing is that these are some different flags, and what you're doing with the Makefile is that these are different things at the very beginning that you can do in order to basically assign reusable constants that you want to then basically substitute in wherever you have this $sign in parentheses later on throughout it. So anywhere in which I have this $sign parentheses and C flags, it's just going to get replaced with these ones up here. And same thing for CSX getting replaced by this one here. And basically it means that in case I need to change my compiler, I can do it in a single spot in case I want to change whatever flags I'm using. So things such as O3 is for optimization, WAll happens to be for basically outputting every single possible error, even those that are just warnings, so as that you can see everything that's going wrong with the compilation process. So it's good for finding bugs. Then the step down here is that you really need to start off somewhat near the bottom here, because what's going to happen is that these act somewhat similar to this. And when you use a makefile using Linux or the like, what you would do is you would type make, and then you would tell it whatever one of these you end up wanting it to end up doing. So in this case here, I would go with something such as make all. And what it would then do is it would go, all ends up just having HW, so it then substitutes in HW for this, similar to how I was doing the substitution of this for C flags and this for CXX. So what it then does up here is it goes, okay, I need this one, and it does a whole bunch of those. And basically what's doing here is it's doing, once again, the same sort of substitution thing, similar to what it was doing with all to HW. So it's doing HW, okay, we need to go to HW1.0. And the reason why this is HW, for those wondering, is because this was a homework assignment, so I just went with HW for it. And HW1 was just a more general one for the main file in that homework assignment. And then you can also see how it does stuff such as faces, vectors, transforms, and this is all stuff we're going to get into in the future when we deal with graphics. However, basically what it's doing is that, in case you remember in the previous one how I described that it creates a translation unit, each one of these .o files ends up being basically a translation unit. So it's doing this compilation on each of these, and then up here, it's finally linking all of those O files up together. And then the last thing it's doing here, and this just is for Linux stuff, or more accurately Unix, is that it happens to be removing a whole bunch of the stuff that frankly we don't need to have in that folder anymore that get created by the compilation, because it's going to create all these O files, and unless we tell it to get rid of them, it's going to end up just keeping them around, which is also why down here you'll see this clean, which cleans up everything that gets output. So down in here, and you can sort of see how this does the separate compilation. Material ends up relying on material.h and utility.h, so includes those header files. Doesn't need to include any CPP files for them, because in the previous one, as I mentioned, it ends up basically having function pointers to specific spots in memory that will end up being replaced by whatever ends up being coming out of the compilation of utility, which you can see up here. Then, same thing for light source, where it relies upon the two of those. Our RGB vector, our 4-length vector, 2-length vector, and so on and so forth, how each of these only include a set of header files that it needs and the CPP file. In the event that it were something such as what we're having to do over here, where we have to end up including CPP files throughout some of this, then we're going to wind up with some bigger concerns in terms of the fact that I would have to include something such as vector4.cpp in addition to vector4.h. But because it isn't templated, I don't need to actually include that. So you can see how it creates these different translation units, and then at the very end of it, once it has gone through and created all of these translation units, what then does, and this is the difference here, is that this -c is telling it to compile, and then this -o basically is telling it to link together a bunch of compiled translation units, and it then goes through, takes in all of them, does the final bit of linking for them, and generates your executable. So that happens to be sort of a more advanced thing that you can do with this. For Windows development, they aren't really necessary. They're useful to understand what's going on. However, your IDEs, such as Eclipse here, such as Visual Studio, will end up taking care of this for you. And they have a different means of controlling the build in it, because such as up here, how we have this, there's build configurations. We can set our properties. Let me quickly actually do that so as I can access some of these properties. And you see how in here in build, we have a whole bunch of different stuff going on in here. But the mere fact that we end up including all of these files within our source and within our project here, that all ends up making it so as that we have effectively a makefile automatically able to be generated for us without us having to do it. So I hope that gives a bit of a clearer issue as to what the potential problems you can run into with the linker are, and a bit of a better understanding of the linker than maybe our previous explanation gave, or at least a more full understanding of it. So thank you very much for watching. Have a wonderful day.